Hello, my name is Gerhard Adam, and in this module we will take a look at multi-step jobs, basically continuing the discussion that we started, and look at coding JCL with multiple steps. With multiple step jobs, what we are dealing with is the ability to run these various steps and pass information between steps. Now, the steps don't have to be related to each other. They could simply represent a whole series of operations that are occurring to perform an overall function. But because of the fact that we do have the ability to pass data sets, and we have the ability to pass temporary data sets between jobs and between steps, then what we have is that we have a useful way then of being able to code up a whole series of processes that we want to do. And in the event that they may take hours to complete, they can run unattended then. And so in addition to this, one of the things that we can do is that we can incorporate a certain level of logic by testing condition codes. And with condition code testing, what we're able to do then is we're able to determine whether or not a particular step should or should not run. This allows us to also build steps within our JCL that are contingent on success or failure of previous steps. That way, if we have a step that had a questionable return code, then we can bypass running the step and ensure then that nothing is wasted as far as resources in running something that's going to produce a null result for us anyway. In other cases, what we could do is that we can actually cause a step to run because of a previous error. And as a result, we might be able to initiate a recovery process, or perform some other action that is going to handle our data sets or get things set up so that in the event that we have to do a restart on this job, we're able to do that. The JCL then, of course, is going to then conditionally execute based on these previous completion codes, and we can check anything that occurred prior to the step that is currently running, including abnormal terminations. And as a result, this gives us a tremendous amount of flexibility, depending on how sophisticated we want to make these procs, to establish exactly what the conditions for execution are. In many cases, it may be very simplistic. We don't have any condition code testing. We just simply run each step as it occurs. In the event that we have a failure, then there's a restart process that we're going to engage in, and we simply restart the job. In other cases, though, as I said, we could be much more sophisticated and employ this condition code testing as a kind of logic that we can use then to build a rather sophisticated process. In this case here, again, looking at the JCL example that we had just seen earlier in this last module, we're looking at the assembly proc, and in this case the overrides as we'd indicated for step C, for step L, and for step G. And the idea here is that again what we have is that we have a three-step proc where we have the assembly, we have the link, and then we have the execution step, or the go step as it's called, in order to be able to perform these actions then. So that way, instead of running three separate jobs, we can run one job and we can pass the information, get rid of anything that's temporary that we don't need to retain, and then in the end, see the execution of this all within a single job. In this case here, again, reviewing the output that we had just seen the example of in the previous module. In this case, again, we are looking at where the overrides occur. Now, statement 13 shows the override and, of course, the / as we'd mentioned before, for linking. However, notice statement 9. Statement 9 provides an override for sysin, but there is no sysin statement. As a result, what happens with the JCL is that in this case, he uses the step C, searches for any matching DD names. If there is no matching DD name, then the override occurs as the last entry within that step. So as a result, what we have then is we have the C.sysin representing the last DD name within that step. And since there's nothing specifically to override, it is simply added to that step as an additional DD statement. One of the other elements that we can deal with is restarting a job, so that if we have multiple steps, very often it's important for us to be able to determine whether or not a job can be restarted in the step that's failed, or whether there are any additional requirements for restart. So one of the things that has to be designed into a job is to determine how can it be restarted. In the case of the assembly link and go, we would typically rerun right from the beginning because of the fact that typically an error is going to be in our source code. We correct the error, we simply rerun it from the beginning. The entire proc is defined as a series of temporary data sets, so none of them will be retained when the job ends, and as a result, we can run directly right from the beginning again. But suppose that we have a job that it runs for an extended period of time. Maybe it runs for several hours. And so certainly, if we have a step that's completed successfully, we don't want to go back and rerun the same step again. More importantly, there may be instances where we can't rerun the step. Perhaps that step is updating a database. Maybe it's updating account information in a bank or something like that. And so as a result, we can't rerun it because of the fact that we don't want to apply updates twice, or we don't want to produce erroneous results by trying to do updates that have already been done. So as a result, we may need to restart that job then in the step that failed, rather than just arbitrarily starting from the beginning. In addition, sometimes we may have a failure where databases or files have been partially updated, in which case the restart considerations may involve restoring data sets from a backup so that we can in fact rerun from some previous point in time and reapply updates or changes that we are making. So the entire concept or the process of restarting a job can get to become quite complex depending on the level of recovery that we need, the type of activity that was being performed, and our ability to restart at any particular point in time. So essentially, we could either start right from the beginning, we may start from a failing step, or we may be able to restart from some other previous step that gets us set up. Also, when we restart, we have to consider how our JCL looks. Are there any conditions in there that depend on previous steps? For example, if we had a refer back coded. This is precisely what I meant before about the liability, because if we bypass a step that has a refer back in it, it's not going to work if that step we're referring to has been bypassed because of a restart. There will be no values that have been interpreted for it, and as a result, the refer back will fail. If we are creating data sets, for example, that are new and they didn't exist prior to this job, we may have to delete those data sets so that when we rerun, we can recreate them. Things of that sort are going to also be factors that are going to play into how we can restart a particular job. So in every situation then, we're going to have to evaluate what those requirements are and what the easiest approach is going to be. We can always do it the long way, which is simply delete and undo everything that we did and just rerun from the beginning. But as I said, that can also introduce its own set of errors, and in some cases it's simply untenable if it involves several hours worth of processing, or it requires making a large number of changes that may be much more complex to make than it is to just simply restart or restore from a particular position. If we have symbolic parameters, do those need to be changed? Are there any differences now that we can potentially use to override those values? Because very often this is one of the reasons why symbolic values are used in procs, is precisely in the event of a restart, we may be able to change the disposition of new to a disposition of old, and things of that sort that can be useful then to facilitate a restart in a situation like that. So the restart parameter then is going to be coded and basically allows us to specify on the job statement which step or which step within a proc we want to restart in. So essentially what we have then is that we have this refer backs being invalid for any bypass steps. We need to be conscientious about what values are necessary so that we don't compromise the rerun, new data sets that were created and things of that sort. And so as a result, what we want to look at then is we want to take a look at a demonstration here about what restart processing does and how we can facilitate that. So in this particular instance, what we are going to look at is an example of a three-step job that is used to install a particular software product and create the libraries. And so essentially what we have is the first two steps involve creating all of the necessary data sets, and then the third step involves updating one of the files that was created. If we have a problem, we would either have to go and delete everything and start over, or we could restart in the failing step and simply bypass the previous steps. So let's take a look at what that would look like. In this particular example, we have the JCL that is used in order to allocate the data sets necessary to install a particular product. And as I said, there are three steps involved in this job. Now in this case here, you can see statement number 2 has a restart parameter coded, but it is commented out. This is often a technique that is used where a restart might or might not be necessary, so that it can be coded and simply commented out so that it has no effect when you're running it normally, but when you need it, you can simply remove the asterisk and make this a general statement. So in this particular instance, what we would do is we can take a look at the JCL, and when we scroll past all of these comments, what we will see then is the first step here defines a particular file. We can see the control statements that are coded here for this, and then we can see that we have another step here, the execute for program equals IEFBR14. This allocates a whole series of data sets, and then you can see that we have a final execute for program GIM SMP. So this is the third step. Now, since the previous two steps create new data sets, in the event that we have a problem in this third step, then we cannot rerun the first two steps without deleting all of the data sets. Now, that can get to be rather tedious because there can be a large number of data sets involved. And so going through that work in an effort to rerun becomes a lot more cumbersome and a lot more difficult. Whereas it's much easier if we can say, well, look, steps 1 and 2 ran successfully, so rather than rerunning them or deleting things so that we can rerun them, let's just bypass them. And what we can do then is we can simply use the restart option here. We've identified the step name, and by removing that asterisk, now when I submit this, it will simply start in the third step, bypassing the first two steps. This is what the purpose of restart processing is. Now, as I said, this is a very straightforward, simple example of where we can simply start within the step that failed. In many production environments, it can be much more complex than that once you consider the files that are updated, the availability of the data, what steps need to be rerun, different things that could affect the outcomes. In those cases, then, usually production jobs will have well-defined restart procedures so that depending on where the failure occurs, there would be specific instructions in how to restart that particular job. Again, normally production control folks are going to be in charge of managing that in the event of a job failure. But it is a consideration that the role of the restart in this case is to help you avoid having to rerun work that's already worked successfully and allow you to simply bypass those steps that have been problematic.